Welcome to Reality Radar, the channel where we explore the most mind-blowing concepts in science and philosophy. I'm your host, Lovish. Have you ever pondered over the question, can the mere act of observing change the outcome of an event? If it sounds like something straight out of a science fiction novel, welcome to the fascinating world of quantum mechanics. In the realm of the minuscule, things don't behave like they do in our everyday world. This is where the observer effect comes into play. The observer effect suggests that the act of observation can affect the outcome of an experiment. In simple terms, by just watching, we can alter what happens. To better understand this, think about a spinning coin. In our day-to-day life, the coin is either heads or tails, but in the quantum world, it's both heads and tails at the same time until we look at it. This is known as superposition, a fundamental principle in quantum mechanics. Just like our spinning coin, quantum particles can exist in multiple states simultaneously. But the moment we observe it, the superposition collapses and the particle settles into one state. But how can this be? How can our mere act of observation influence the behavior of particles? This is where the concept of wave function collapse comes into the picture. A wave function provides us with all the possible states a quantum system could be in. When we observe a quantum system, we are forcing it to collapse from multiple possibilities into one single state. Another key idea is quantum entanglement, where two particles become deeply linked and instantaneously affect each other no matter how far apart they are. Imagine two entangled particles, one in London and the other in New York. If we measure the state of the particle in London, the state of the particle in New York will instantaneously collapse to a corresponding state. This spooky action at a distance, as Einstein famously called it, further emphasizes the role of the observer in quantum mechanics. Now, does this mean that consciousness plays a significant role in quantum mechanics? After all, it's us, conscious beings, doing the observing. The answer to this isn't straightforward. Some interpretations suggest a link between consciousness and the collapse of the wave function. But many physicists argue that the observer in quantum mechanics doesn't necessarily have to be a conscious being. It could be an inanimate measuring device. So, where does this leave us? The observer effect is a cornerstone of quantum mechanics. It tells us that the act of observation can directly affect the outcome. It's a concept that challenges our understanding of reality, blurring the line between the observer and the observed. In the quantum world, things are not as they seem. Particles can be in two places at once, can pop in and out of existence, and can even affect each other instantaneously over vast distances. And in this strange world, the observer plays a crucial role, with the act of observation shaping the very reality we seek to understand. But remember, quantum mechanics is still a rapidly evolving field, and our understanding of it is far from complete. As physicist Richard Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." The observer effect is just one piece of the quantum puzzle. There are many more pieces left to place before the picture becomes clear. So, the next time you find yourself observing something, remember, in the quantum world, your act of observation could very well be shaping the outcome. And with that, we conclude our journey into the observer effect and its role in quantum mechanics. A journey that takes us into the heart of one of the most intriguing and perplexing theories of modern physics. It's a testament to the power of human curiosity and our relentless pursuit of understanding the universe we inhabit. So, keep observing, keep questioning, and keep exploring, for who knows what we might discover next in this grand cosmic dance.